Yesterday we looked at linear combinations, and we also talked about the standard form of the equation of a line. Now, that's where we're going to pick up today's notes when we talk about graphing the standard form of the equation of a line. If you remember, that was ax plus by equals c. So when it comes to graphing the standard form of the equation of a line, we actually can use the intercepts. That's the x and y intercept. So in order to find the x-intercept, we're simply going to substitute 0 in for y and solve for x. That will give us our x-intercept, or where it crosses the x-axis. Likewise, to find the y-intercept, we're going to substitute 0 in for x and solve for y. And that will give us where it crosses the y-axis. Let's take a look at an example here to see how this works. We're given the equation negative 3x plus 2y equals 12. I'm going to write this just a little bit larger here so we can all see that. This is a standard form of the equation of a line. I see that a value is negative 3, my b value is 2, and my c value is 12. The powers on x and y are both equal to 1. So this is a linear combination written in standard form. Let's start off by finding the x-intercept by plugging 0 in for y. Well, if I plug 0 in for y, it's kind of like ignoring that whole term, because 2 times 0 would just be 0. So I have the equation negative 3x is equal to 12. Divide over that negative 3, and x is equal to negative 4. That means it passes through my x-axis here at negative 4. Next, we're going to find the y-intercept by plugging in 0 for x. So let's come back up here to this top equation. I'm going to erase that x through my term 2y. When I plug in 0 for x, it's kind of like ignoring that first term and just solving the equation 2y equals 12. Well, let's divide over both sides by 2, and I get a y value equal to positive 6. And that's my y-intercept. So I'm going to come up here on my y-axis and plot that point here at 0 over and 6 up. Now, I have 2 points, and it only takes 2 points to construct a line. So I am going to draw a line through those 2 points, and I'm going to say that here is the line of this equation, negative 3x plus 2y is equal to 12. So you can see I have a y-intercept of 6, and I have a slope here that I can count by counting my rise over run. Let's just quick do that a minute. Count 1, 2, 3, 4, 5, 6 as a rise, 1, 2, 3, 4 over. So I have a rise of 6 and a run of 4. So that means the slope of this line is 3/2, and the y-intercept is equal to positive 6. If I wanted to, I could check this line by writing it in slope-intercept form. And I would write y equals 3/2 x plus 6. And there it is in slope-intercept form. All right, let's try another example using this idea of intercepts. Here's another equation of a line. I have 4x minus 5y is equal to 20. I want to find the x-intercept by plugging 0 in for y. So remember, that's like ignoring that term in the equation. And what I'm left with is just 4x equals 20. When I divide both sides by 4, my x-intercept is 5. So let's go over on the x-axis and plot that. Next, I'm going to do the same thing by plugging 0 in for x and finding my y-intercept. So when I do that, it's like ignoring this first term, and I'm left with negative 5y equals 20. Now be careful, make sure you take that negative with the 5 because it belongs to the 5. So dividing both sides by negative 5, I get a y value of negative 4. So looking on my y-axis here, here's negative 4, and again, I'm going from left to right to connect these 2 points, and here is the graph of this line in standard form. All right, a few more types of terms or types of lines that you guys have learned about in the past. These are horizontal and vertical lines. Well, horizontal and vertical lines appear in standard form if a is equal to 0 or b is equal to 0. Specifically, you'll have a horizontal line if a is equal to 0 because what you'll be left with is just the equation by equals c. And when you solve for y, you'll get y equals c divided by b. And this is going to turn out to be a horizontal line that passes through the y-axis at this point, whatever c over b is. Now, if b is equal to 0, you will actually have a vertical line. That's the one that goes straight up and down. And if you see why here, if we put 0 in for b, you're going to be left with the equation ax is equal to c. And if we divide over that a, you're going to have the vertical line x equals c over a. And this will be the vertical line that passes through the x-axis at c over an a up. Or sorry, at c over a. All right, moving on, let's just do an example here. We have the graph, or we want to graph the standard form 0x plus y equals negative 2. Well, here you can see that we already have 0 in for x. So that really just ignores that term, and I'm left with the equation y is equal to negative 2. Well, that's going to be a horizontal line, and it's going to pass through the y-axis here at negative 2. So there it is at negative 2. Any other point on this line is going to have a y coordinate of negative 2. So here's our horizontal line that passes through that y-axis at negative 2. All right, one more concept that we want to introduce to you guys today. You've actually learned about equivalent equations way back in Unit 1. Now you can have equivalent equations when it comes to standard form or these linear combinations here. And these equivalent equations will just be multiples of each other. The result will be that they have the same x and y intercepts. So we can test to see if two equations are equivalent by checking their x and y intercept, or by checking their slope and y-intercept. So let's check our x and y-intercepts for all of these equations by simply covering up the each term and solving for the other. So let's take this first one here. Solving to find the x-intercept, I cover up the y, divide over the 2, my x-intercept is 6. All right, now we're going to solve for the y-intercept by covering up the x and solving for y. Divide that 12 by negative 4, we get negative 3. Let's go to the next equation here. 2x plus 4y equals negative 12. Solving for the x-intercept, divide over that 2, I'm going to have negative 6. If I solve for the y-intercept, I'm going to end up with negative 3. All right, equation here in the letter C. Again, I'm going to find my x and y intercept. I can find my x-intercept by covering up this y term. Divide over that 2, I get negative 8. And now when I find my y-intercept by covering up my x term, I'm going to get negative 4. Oops, that's a negative 4. And finally, my last equation here has an x-intercept of negative 6 and a y-intercept of negative 3. So looking across all four of these, I'm just going to rewrite this one a little bit better here. I see that my x and y intercept for this equation here in letter D and my x and y intercept for this equation here in letter B are exactly the same. So these equations would fall on top of each other, and they would be the same line, and therefore they are equivalent equations.